This conference will now be recorded.
Good morning, friends. Welcome to GoOnlineTrainings.com. Today, we're going to be seeing very important topic, that is how to perform incremental loading, called as a delta loading, or is also called as partial loading. Clear? So this is a very important topic. In all the interviews or every interview, you're going to be getting this question. So what do you mean by incremental loading? How did you perform incremental loading? What are the issues you're getting while loading the data? So with the help of incremental loading, what did you use to implement this? Okay, a lot of questions are asked, and let us understand what is incremental loading and delta loading and what are the things that we have. Let me go to Excel and let me take, this is my source. Okay, I have some data here. So the table name is, let us say, employee table, and I have an employee ID, employee name, employee ID, employee name, and I have employee salary. Okay, so this is what we have. I have some data. One, John's salary is $1,000, and two, we have Raj salary is 2,000. So what I have done, I have created one SSIS package. Now I create one more blank table. The name of the table would be, if it is in data warehousing, okay, if it is in data warehousing, and this is a source may be called as OLTP, right? So here we are going to be having OLAP, or you can say data warehousing environment. In the data warehousing, so this table is called as a dimension table. What is a dimension table? What is a fact table? You need not worry as of now. So because as soon as SSIS gets over, I'm going to be starting data warehousing concept from start to end. So I assume that you don't know anything about data warehouse. Clear? So I'm going to be starting a fresh, very basic starts, basic classes I'm going to be taking. So don't worry about it. So we're going to be creating a table called a dim employee table. So the same columns will be there. This is the dimension table. So data warehouse will have two types of tables. One is called dimension table. One is called fact tables. OLTP also will have two types of tables. Those are called master tables and transactional tables. Clear? So always data is two varieties. Any data you take it, data is of two types. One is called OLTP data, OLAP data. That's it. So you may have two varieties of data. One is called OLTP data, or OLTP apps data, or OLAP data, or we can say data warehousing data. Clear? So if somebody asks you what is OLTP and somebody asks you what is OLAP, only one answer you need to give them. OLTP means fresh data. If somebody is saying, I have OLTP application, what is the meaning of this? OLTP means online transactional processing data. In the layman terminology, OLTP means fresh data. Wherever you're storing a fresh data, that is what is called OLTP data. Okay. What is OLAP data or data warehousing data? If somebody says, I have data warehousing data, I have OLAP data. So what is the meaning of? It is historical data. That's it. Nothing else. If somebody says, I have an OLTP, I have OLTP data, I have OLTP application, I have a .NET application, that is OLTP, I have Android application, that is OLTP application. That means what? You need to understand OLTP refers to fresh data. For example, I am buying some product today in Amazon.com. That is a fresh data I have ordered. But I have ordered lot of items last year also. That is historical data. Clear? OLTP means fresh data. OLAP or data warehousing means historical data. That is what you need to understand. In OLTP, there are two types of things are available in OLTP. OLTP will have fresh data only. So data warehouse also will have a fresh data. OLTP will have two types of data. One is called master data. The second one is called transactional data. Clear? OLTP applications will have a customer master. People will be giving the naming convention also like that. Employee master, product master, because they're trying to say it is a master table. Clear? So transactional tables, people are going to be calling these two tables in OLTP databases. So if you take Amazon Amazon business, Amazon will have a OLTP because whenever you order something through Amazon site, Amazon Android phone, that is a fresh data. Fresh data is going to go to one database that is called Amazon. That is the OLTP database. So Amazon is getting from a website called Java website or .NET website. .NET website is getting the data, that is OLTP app. The data is giving to the backend database called Amazon. Amazon database is called OLTP database. This website is called OLTP website because it is capturing a fresh data. Today's transactions are getting inserted into this. So what kind of a tables Amazon has? Master tables and transactional tables. But if you create a data warehousing, because you cannot keep all the data into OLTP forever because the database size will increase. So what they do, once in a while, they will be taking all the data from OLTP, they're pushing into data warehousing with the help of SSIS or with the help of ETL. So once in a month, they take all the data from OLTP, they'll be putting into OLAP. So from moving the data from OLTP to OLAP, we're going to be using ETLs. Clear? So now what kind of a tables we're going to be creating? We're going to be creating dimensional tables and we're going to be having a factor tables. Clear? There are two types of tables in OLTP, master tables and transactional tables. In the data warehousing, we'll be having dimensional tables and the factor tables. Now remember, we have data could be OLTP data could be data warehousing data. So data analytics done on what? Is it OLTP data or historical data? Data analytics always done on the OLAP data, data warehousing data, historical data. Nobody is going to be doing data analytics on today's sales and transactions, right? So you can do a small reports, but not data analytics always is done on the OLAP data or the data warehousing data, not on the fresh data. You cannot do any kind of a big analytics cannot be done. So analytics means you need to have a large amount of data and a lot more of historical data. Then only we can analyze the business very quickly. For example, you wanted to analyze how is Bhaskar sir. By seeing one day's behavior, can you analyze? You cannot. If you wanted to analyze Bhaskar sir, you need to see past 30 years of his behavior. What is he doing? How is he studying? What is he doing? So you need to have history of the Bhaskar. Then only you can predict something or you can analyze something, right? So data warehousing applications will have lot of data. So historical data you will have and more data. Large amount of data is available here. Last 10 years of data is available here. And here fresh data, probably last 1 month data. You're having less data here compared to OLAP, okay? So OLTP databases are maximum 500 GB, that's it. But here you may be having 100 terabytes of data, 1000 terabytes of data, it will be having. So OLTP, you just like assume just like a bucket. Bucket is 35 liters of water that can carry the fresh water. But when the bucket is full, we're going to be dumping the water into a tank or the drum. So you have thousands of buckets of water will be available in your in your drum or the tank. That is what is called your warehouse. Warehouse is always available in the terabytes, and your OLTP applications will be available in the 500 GB because you have fresh data. When the bucket is full, 45 liters or 30 liters you can have in the bucket. When the bucket is full, what you do? You take the water and dump into your drum or the tank. So the tank is called a data warehouse. the fresh water is available in your buckets. So OLTP databases are just like buckets. Only it will take the fresh data and limited data. And once the database is full, you're going to be dumping the data into the drum or the tank. Clear? That's what you need to understand. So data analytics always done on the maximum times, not on the OLTP data, on the OLAP data, data warehousing data. Even tomorrow, people saying, I'm going to be working on the Hadoop system. We have Hadoop technology, right? So Hadoop. So Hadoop is also one more technology. When you have large amount of data, it can store data, it can process the data. So Hadoop is storing data. What kind of a data you're storing? Hadoop is also can storing the data. Hadoop is also processing the data, right? So BI applications are also storing data and it is processing the data. If you take BI, MSBI, SAP BI, all of them are storing the data. So all of us are doing only two things. What are they? Storing and processing. So nothing else. So how are we going to store in BI? BI for the storing purpose, we are going to be using DWH. For the processing purpose, we are going to be using SSIS cube to process the data. Okay. Cubes are built to process the data. Here, how are we storing the data? In files, HDFS, we're going to be storing the data. For the processing purpose, we're going to be using MapReduce. Okay. When should I use BI? When you have terabytes of data, you can go in for BI. When should I use in, this one? When you have a petabyte of data, zettabyte of data, yottabyte of data, yola-byte of data, when you have this much of a data, the normal BI system is not going to be working. So it is not we're going to be using. But here we're going to be using storing data warehousing. That means we're storing historical data. But HDFS, it is also storing what kind of a data? Here also we're having OLAP data only. OLAP means what? OLAP data, people will say data warehousing data. Okay. So people will say batch data, batching. Okay. So people will say batch system, batch applications means it leads to OLAP and data warehousing. Okay. End of the day, Hadoop is also having a OLAP data, data warehousing data, batching data. Batching data means historical data, old data, large amount of data. Clear? So whether you use Hadoop or BI, big data Hadoop, people will say, in my company, we are using Hadoop. Why? Because they have unlimited data. So terabytes, if you have only, you can go with the BI. But if you're getting every month a petabyte of data means data warehousing and BI will fail. So that is when you need to stop BI and you need to switch to Hadoop. Clear? End of the day, Hadoop is also storing a large amount of data. What data it is going to be storing? It is going to be storing again OLAP data, data warehousing data, batch data, but it is not going to be storing in the data warehousing. It's going to be storing in the files, HDFS, Hadoop distributed file system. This is what is the concept Hadoop is going to be implementing. Hadoop is not storing any data into the data warehousing. But if you wanted to have a data warehousing as part of Hadoop, yes, you can have. You can also create one data warehousing here, and the data you can give it. So you can create a data warehouse data. Okay, you can have a data that can be stored in the data warehouse, and the data will be going to HDFS. From HDFS, it's going to be reading. Clear? So where Hadoop is going to be implemented means when BI stops working for the company. When BI stops working, when you have unlimited data. When you have unlimited data. For example, I have a tank. So if the one tank is over, I can go for one more tank. When it is taking for me 5 years to get the one tank. So after 3 years or after 5 years, I'm buying one more tank. I'm putting all my new data into one more tank or one more data warehouse. So I'm having 5 years to fill one data warehousing. Okay, if that is the case, people may implement every 5 years, they buy hardware, they implement software, and they'll be putting lot of next 5 years data into one more data warehousing. And after 5 years or after 10 years, that is also full, then they are going to buying one more data warehousing, and they'll be implementing the next 5 years data is going to go to one more hardware. That means what? A company having a lot of data warehouses to store their data, because one data warehouse cannot be implemented forever. But it will take for them to fill one data warehouse, it will take 5 to 7 years or 5 to 10 years. So there is no problem, they can invest money 5 to 10 years and all the data. But now let us have one more situation. Every 1 month, one tank is getting filled, one data warehousing full, one data warehousing capacity, let us say 100 terabytes. Let us think like that, okay, or 50 terabytes, something like this. So every 15 days your data warehouse is full. Every 15 days you need to buy one more data warehouse and install the software and buy get the data again. After 15 days you need to buy one more data warehousing. Then people cannot use data warehousing, people have to jump from data warehouse to what? Data warehouse to a Hadoop, because Hadoop is going to be storing unlimited data. Okay, so here also we are using many data warehouses, but each data warehouse will have 5 years to 7 years time to fill. But now I'm giving you one more scenario. I am having some data, I have implemented in a data warehousing. Every 15 days one data warehouse is full. I am not waiting for 5 years, 10 years. So that means you have more volume of data in both places. Remember this, volume of data is there. Volume means I have terabytes of data. Here also I have a volume of data. That is also fine. I'm getting terabytes of data, but still my business is implementing this. Okay, because here speed is very, very important factor. Velocity or speed. Speed is, let us say velocity. One more point that is very, very important. Velocity means every week you are getting 100, 200 terabytes of data. Here velocity, when you say every 5 years that I need one more data warehouse, or every 7 years I need one more data warehouse. Even though I'm getting terabytes of data, but not 5 to 7 years of data, I'm getting, let us say, 100 terabytes of data here. I am having every 1 week I'm getting one more 100 bytes of data or terabytes of data. The speed is also too much. When you have a velocity is more, speed is more, you cannot do this. Okay, so this is volume. Volume is also I'm getting terabytes of data, but speed in which you're getting the volume is important. So you're getting 100 terabytes of data for 5 to 7 years of time. You're getting 100 terabytes of data within one day, within 2 days, within 1 week. So velocity is too much of. Then you have variety of data. People are going to be calling this. Variety of data means you have structured data, right? You have structured data means we're talking about rows and columns data. You have semi-structured data. We have XML files, or you have unstructured data. Unstructured means images, audio files, video files. If you wanted to process this kind of a data, then Hadoop is going to be used. Hadoop, people are going to be saying 3 V's. 3 V's means what? People are going to be saying it is going to be giving solution for the 3 V's: volume, velocity, and variety. It is going to be taking the volume, but up to some volume, and if you have more time. And velocity, if you have more and more speed, you're getting the volume of data, then it cannot implement. Then variety, you have only structured data, rows and columns data, because the storing here data warehouse. Data warehouse means it is a database. Database means you have rows and columns. When you have rows and columns, that is called as a structured data. BI can take only structured data and little amount of data, up to terabytes of data, and the data not coming very uh, quickly in speed in which it is not getting the data. So it will take 7 to 10 years of time to get the 100 terabytes of data. If that is the case, people are going to be using BI to perform. Okay, so BI is going to be using data warehousing, which is only for the structured data, and the volume we can have terabytes, not more than that. If you have a lot of terabytes of data, then you can distribute the data. Data warehouse number 1, data warehouse number 2, data warehouse number 3. For example, Amazon may have a data warehouse for India. Amazon may have data warehouse for Europe. Amazon may have data warehouse for UK, something like this. So it depends upon situation. So if I store everywhere complete data in one place, it is more data. So they will be having different data warehouses. Clear? So that is their situation. So in India, they have implemented data warehouse. They at least they can accommodate. So next 10 years of data into this data warehouse, then they will have one more data warehouse for India for next after 10 years, something like this. Clear? But if they wanted to implement, whatever be the reason, if they wanted to implement only complete data should be there in one platform, means instead of having different data warehousing, they can switch to Hadoop. Clear? So Hadoop, we are going to be storing the data. It can have, as it is data warehouse, all Hadoop can integrate with other existing data warehouses. It can take the data and it can dump into HDFS. So from there the processing can be happening. So Hadoop and BI are going to be having what kind of a data? OLAP data. It is called as the data warehousing data or batch processing systems. These systems are called as batch processing. When you say batch processing, when you have a large amount of data, when you have very little amount of very small amount of data, nobody is going to be using batch processing. Batch processing means at a stretch I have to take thousands of rows and do the processing. If I wanted to do row by row operations, so row by row operations are available in your OLTP. Batching operations are available in OLAP, because in OLTP, you go to the bank and what is that you ask? You go to the bank, you ask, what is my balance? Now, will you access large amount of data? Only one row. You're going to be asking a question, what is my balance? That is OLTP, way of asking. So it will access one row and it will tell you, this is your balance. You will you go to OLAP and ask what is my balance? OLAP is going to be having historical data. Nobody is going to be asking that kind of a question in OLAP. In OLAP, people are going to be asking, what is the sales happened in India 2005 to 2010? This is the question asked in OLAP or in the batch processing system. Clear? So even though we have data in two places, the questions are asked differently. I wanted to see last 3 months of transactions. That is the OLTP question. But in OLAP, I wanted to have last 10 years of patterns, trending patterns I wanted to see in my OLAP data. Clear? So that is how we're going to be asking. You go to the OLTP and ask, I have deposited yesterday a check, whether it is successful or not. Right? So whether I received the amount or not. So that is how we're going to be asking in OLTP. But in OLAP, it is not like that. So how many people have repaid the loan amount? How many people couldn't pay the repaid the amount? And where we had given more loans, but we could not get the amount properly. Where the loans are given more, but collected amount is less. This kind of a questions are asked in the OLAP. But both data is a bank database data. So you understand what is my balance, that is you're accessing a single row, and what is the sales in the India in last 5 years. That is also one more question asked. So that is asked in the OLAP system, data warehousing system, and it is completely batch processing system. Clear? So when you take Hadoop, same questions are asked again. I wanted to understand in last 10 years what was the sales happened in India. So that is the question asked to Hadoop. Hadoop is going to be having a lot of data into this, and we're going to be processing the data. When the data is available here, so if you have data in the data warehouse of Hadoop, you can get the data to HDFS. From there, we're going to be taking map reduce help. With this help, we'll be able to achieve this query. What is the query? In India, last 10 years, what is the sales happened for given product, or given bunch of products, or given categories, a category called home appliances. Clear? So you need to understand Hadoop and BI as well. Both of them are going to be dealing OLAP data, historical data, data warehousing data, batch processing systems. These are, remember these points. Clear? So there is a two types of data in this world. One is called as OLTP data. The other one is called OLAP data. How Hadoop is also going to get the data from OLTP applications only, or Hadoop also may get from the data warehousing applications. All the data you may be dumping into end of the day in single Hadoop systems. Clear? And BI is completely centralized system. Okay? BI is completely centralized. All the data is going to be centralized, right? So that is what you need to understand. But Hadoop is not centralized, which is completely decentralized. Remember this. Hadoop is not going to store data in a single machine. Hadoop is going to be storing the data in across machines. Clear? Hadoop is not a single machine. Try to understand, but data warehouse is a single machine. Okay, it is not going to span across machine. It is a single machine. So people will say it is a cluster. Hadoop is a cluster. Cluster means what? Cluster means it is going to be having a couple of machines, not only one machine. It is Hadoop is not a single machine where you install the software. No, it's not like that. Hadoop is thousands of servers, thousands of servers. It is going to be storing the data across machines, because when you have unlimited data, I cannot store in a single place. So definitely Hadoop is not a single machine. Hadoop is a collection of machines and group put together. Clear? So that you need to understand. We'll discuss one time the Hadoop architecture as well, so that you can have what kind of a things are available in the market for data storing and data analysis. Data analytics means you may implement BI or you may implement big data Hadoop. Clear? So here we're going to be having structured data, less volume of data, terabytes of data, centralized. All the data is centralized. Here data is in petabytes, volume, velocity, variety, and different varieties of data. And the data is not in the single machine. It is available in collection of machines. Clear? It may be, you may be having thousands of machines put together, and you're going to be implementing that. Am I clear? So we have only two types of data, whether that is a fresh photo or old photo. The fresh photos are getting uploaded today. That is unstructured data, but fresh photo. Clear? So you can have photos also, old photos and new photos, and transactions also, new transactions, old transactions, something like this. So any fresh data that is available in OLTP, any historical data, old data is available in the OLAP and data warehousing. Am I clear, guys? This is very, very important. And all the world has only two types of data. One is fresh data, OLTP data. The data can be structured data, semi-structured data, unstructured data. It could be any data. The data could be structured or it could be semi-structured or it could be unstructured. But what is the data that you have end of the day, that is fresh data or old data? That's what you need to understand. Am I clear? Now, we are talking about data warehousing. So now I have this data. This is the fresh data. It comes here.
Bhaskar sir, before we go forward, on the Hadoop side, when you said that it's all historical data, where does the fresh data go at that time? If you have Hadoop,
They'll have different applications, right? For example, you take facebook.com. Facebook.com is getting a lot of data. Facebook.com will have a database called Facebook. So all today's charts and today's comments, today's photos are getting uploaded into where? A facebook.com. That is a fresh data. That data will be taken into a OLTP system. From there, once in a day or once in a 15 days, this will be going to the a Hadoop system. Clear?
okay, okay, so it will be batch processed as they have scheduled.
Correct, 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 correct.
This is basically nothing but cluster of all the different data, bunch of data warehouses.
Yeah, you can think like this because the model is data warehouse will have only structured data. But when you take Hadoop, Hadoop is going to be dealing with the photos, pictures, audios, videos, unstructured data, semi-structured data. But you can say, you know, you cannot say it is a, a bunch of data warehousing. It is, you can say, bunch of machines, because data warehousing means it has different rules to follow. Clear?
Oh,
So what are the rules we're going to be, deciding later? But data warehouse layman terminology means it is historical data. But Hadoop is going to be having a data warehousing here, but not only data warehousing, lot of other things also will have. Clear? So instead of calling this as a data warehousing, you can say it is a historical data, but the machines are not configured as data warehousing, because data warehouse means you need to follow rule number 1, rule number 2, rule number 3, rule number 4, rule number 5 to store the historical data. Those rules are not followed in HDFS. Clear? Because warehouse is a concept. that you need to follow here to implement a data warehouse. Here, those concepts are not followed at all. Simply, they store data and they say the storage is HDFS. Clear? But you have some data which is available in the data warehouse that you can give it here, because to create a data warehouse, you need to follow rule number 1, rule number 2, rule number 3, rule number 4. But here you may follow, you need not follow that. Clear? So there is no warehousing concept comes into Hadoop. Hadoop will say, simply give me the data. But data warehousing, it is not going to say, you need to follow some structure to store the data. So what are those things we're going to be discussing later? Clear? Yeah. You may have collection of data warehouses are called Hadoop, that is fine, but it may have in the warehouse model, may not be having in the warehouse model, but it's going to be having a historical data, but volume of data is available in this. That is what. You may have data warehouses also, or you may have without a data warehouse also, you can simply give the old data. Clear? Yeah.
Whatever data comes in like Facebook, OLTP flash data just gets transferred to Hadoop without
Correct,
filtering or
correct,
all that.
correct, 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 correct. And one more thing people have to worry here. Always when moving OLTP data to OLAP, here what are we doing? We are performing ETL operations. Extract the data, you have a staging, we're cleaning the data and loading the data. Okay, that's what we're doing in BA. BA always implement ETL. Okay, whenever you store the data here, we're going to be implementing ETL. But in Hadoop, we are not going to be implementing ETL because you have to dump the data tomorrow. So what they take? They take completely this data, they're directly putting here. Okay, so here what they're going to be implementing, not the ETL. In Hadoop, we're going to be implementing ELT. What is ELT? Extract the data, load the data, then you do the transformation here. Clear? So in Hadoop, we never ever perform ETL operation. So 90% of the data of Hadoop, we extract and load it, then we do what is called a transformation. I need the data like this, let me clean it. Let me do it after loading the data, but not while loading the data. Clear? So Hadoop data also we have ETL, but that is what is called ELT. Extract the data, load the data, then transform the data. Clear? So as it is copy, OLTP copy, dirty data, this data, that data, all data, the error data, all the data is going to go to HDFS first and get stored. Then later we're going to be cleaning. So that is how the Hadoop is, it'll be having little bit differences here and there. So it is only one server, it is a collection of servers called a cluster, and we're going to be performing in BA, we're going to be performing ETL operations in BA, MSBI, SAP BA, Oracle BA, any BA, we are having terabytes of data. We are going to be performing ETL operations. We are storing the data into data warehousing, that is structured data. All these are, and end of the day, we're going to be performing data analytics and data science applications are going to work on this. So either in BA or Hadoop, but Hadoop is taking more volume of data, more variety of data, and it is not going to store the data in centrally, and we are not going to perform ETL operations here. You can perform, but most of the time we're going to be using ELT operations. Extract the data, load the data, then however you want it, you transform the data. It is simply shifting your house, from one place to another. What you do? You extract the data. For example, I'm planning to go from my city to another city. I got transferred. So I extract all my luggage from the source and I dump into lorry or on courier service. They take all the luggage. They will be dumping into one more destination. So extracting and loading will happen. So after that, what I do? My wife, my father, my wife, and I'll arranging the saman in the new house. So what is that? That is a transforming. It is arranging whatever we need, that we'll keep it. We'll neatly arrange it. So that is ELT. Extract first from this house, dump it there in the new house, from old house to new house. So we are going. So extracting and loading, then we take 1 week of time, then we completely transform the data. We place the data neatly in our new house. That is what is called ELT. Clear? So ETL means what? You get one box, you open one box and get into the house, and you open the bot, then and there you transform it and you push it there. Clear? That is ETL. You extract it, get the data, and after that what you do? You open the box and neatly you're arranging then and there. That is ETL. Clear? So ETLs are going to happen only in the BI systems, but in the Hadoop systems, you never ever do ETL. You're going to be performing ELT. You extract the data. You load the data to Hadoop, then Hadoop, you write a program. What program you write? You write a MapReduce program and to perform the cleaning and everything. So MapReduce is a Java program. Okay, so you're going to be writing a Java program to clean the data. So again, all the data is not available in a single machine, right? I told you Hadoop is a set of machines. Machine number 1, machine number 2, machine number 3. We have machine number 4, machine number 5, machine number 6, machine number 7, machine number 8, machine number 9. Lot of machines are available. For example, if you have so much of a data, you are going to be distributing all the data to the machines, and you code whatever the code you wanted to write, all the code also will go. Clear? So what happens now? Instead of one guy is doing here in the data warehousing, you have only one guy only doing. One guy will take a lot of time to do that. But if you have three guys, so what happens? Automatically the time will get reduced. Even though you have more and more, what happens? You having more people, more servers, you're distributing the data. For example, I have 100 shirts to be cleaned or washed. If I have only one washing machine, so if the washing machine is failed, then it will be very chaotic situation for me. So instead of having one washing machine, I buy 10 washing machines. I have 100 shirts. What happens now? So 100 shirts will take 1 hour if you in the one washing machine. If I take 1,000 shirts also tomorrow, I'll be putting 100 into 10 washing machines. I'll press button. So what happens now? In 1 hour of time, I should be able to wash the clothes. So even the volume is more. What are we doing? So instead of dumping all the load into single washing machine, what I'm doing, I'm dividing the data. I have 1,000 shirts to be washed. So I'm dividing 100, 100, 100, 100, 100. So what happens now? So here, if the same 1,000 shirts can be washed at a stretch, because now Hadoop is going to be maintaining 100 washing machines or 10 washing machines or 20 washing machines. Clear? So in everywhere you need to distribute the data, and every washing machine you have to put your washing liquid, right? So everywhere you have data get distributed, and code also you need to have it there. Clear? So every machine you need to have the same code to be distributed, data will get distributed, and it started working with this. So 1,000 shirts will get also will get processed in 1 hour's time. Data warehousing will take the 1,000 shirts. It is also having same time. But when you have more and more things comes, what happens? And now you need to buy one more data warehouse. Now that is very problematic here. Here you, without disturbing something, you can simply add a washing machine in the cluster. But in the data warehouse machine means you need to do a lot of big circus. But here easily you can have one more machine, and if something goes wrong, you have 10 washing machines. If one washing machine is not functioning properly, then 9 washing machines will take care of that. But here you have only one data warehouse. If that is not functioning properly, you have a lot of issues. Clear? So more failover is very easy, because cluster 10 machines are available, one machine is not functioning, you need not to worry. Clear? But here you have only one data warehouse. If something goes wrong, you have to have one more backup server as well. Clear? So there you need not maintain the backup servers, because 10 machines, one machine is over means I have 9 machines. Even though 2 machines are not working, I have 8 machines there. So in the cluster, you need not plan for the backups. Here you need to plan for the backups. Clear? Something like this. This is a decentralized architecture and more efficient. Even though you're getting more and more data, you need not buy bigger washing machines. In BI, you have to buy very bigger washing machine to wash 1,000 shirts. But there you're going to be buying a single small washing machine. So the washing machine is not a hi-fi washing machine. Normal washing machine, you can buy it and put it there. Even though you have thousands of shirts, you are distributing 100. So need not have specialized hardware in the cluster. But in the data warehousing, you need to have specialized hardware, because all the data you're centralizing means your more volume. To have the more volume of data, you need to have more specialized hardware here. There, hardware is not specialized, because simple washing machine, you can buy it, You can just distribute the data. You buy one more washing machine, a simple washing machine. Clear? So in the Hadoop architecture, you need not have hi-fi servers. But in the data warehousing, you need to have very hi-fi servers because you're centralizing the data. Where in Hadoop architecture, we're decentralizing the data. Clear? So hardware wise, cheaper hardware, you can have it there. And Hadoop is a free software. You need not pay not even single rupee to anybody, which is a free software. Clear? So, but BI softwares are costly. You need to buy hardware for data warehousing, that is costly, and you need to have, buy the software, that is also costly. But you cannot say, I will implement a Hadoop. I told you one thing, right? So instead of a flight, we have a rocket. So somebody is giving you rockets for free. It doesn't mean that you can use rockets everywhere. So rockets are to go to the moon. You can use the rocket. But if I wanted to come from India to America, I have to use a flight. So you need to have a business intelligence applications as well as you have to use a Hadoop. It doesn't mean that Hadoop is free, Hadoop is good, and Hadoop is faster. Let me use always Hadoop. So that is not the case. Clear? But if somebody asks you, what are the systems that the IT industry has? One is called BI system, the other one is called Hadoop system, big data Hadoop. Clear? Yeah.
Sir, I have a question here.
Yeah, please.
So in old DP means a kind of fresh data, and OLAP means historical data, right? But
Right.
in that diagram, actually, you have categories like master data and transactional data. When
Hmm.
comes to OLAP, dimensional FACNA. So
Hmm.
could you please help us to elaborate a little bit on this? Actually, means what is master, what is transactional?
Yeah, I don't want to elaborate this now because anyhow we're going to be elaborating these two things in the next week as part of our data warehouse sessions. Clear?
Okay.
So master and transaction will be, taking 2 days time to discuss this. So hence I did not give that session now. Okay, I'll be covering what is a master, what is a transactional, what is a dimensional, what is a fact. So when we start data warehousing concept, we'll be discussing all these points. Clear? Yeah, very good.
Okay.
Guys, are you clear? So you need to be clear in this. Okay, nice. So is there any questions? So when should I use Hadoop? When should I use BI? You need to have, but end of the day, how the complete, data of the world or all companies of data is getting stored today? Only in these two systems. One, either you have the data in Hadoop or maybe you have data in the traditional BI. So after this only, we're going to be either using data science applications or we may be using reporting applications. So Hadoop does not have reporting. Try to understand. So if you wanted to, after processing, you're going to be creating a reporting. For that reporting purpose, we may use a Tableau, Power BI, Excel. We may use anything. But BI is going to be having reporting also. Clear? So Hadoop does not have reporting. Hadoop has only two modules. One is called storing and processing. How do you give the data to the Hadoop? With the help of ETL, ELT, right? So you have ETL tools are available. Those are not ELT, ETL tools. They are called ELT tools. Extract the data, load the data, and then later you're going to be transforming the data. So these are few differences between Hadoop and the BA. Clear? So the company may have Hadoop, company may have BA as well. It is not replace. So Hadoop is not replacement for BA. Never, never think. Rocket is not replacement for the flight. Flight is not replacement for your train. Train is not replacement for your car or the bus. No. Your car is not replacement for your bike. Bike is not replacement for your cycle. Cycle is not replacement for your legs. Everything you need. It is the purpose. If I wanted to walk, I need to have my legs. If I wanted to go for cycling, you can have a cycle, right? If you wanted to use a car, you can use car. It is not that. So now we have Hadoop, let us use only Hadoop. That is completely nonsense if somebody is saying like that. Clear? So it is not replacement for anything. It is, if you have this much of a data, the better go in for BI. If you have some other data, better go in for Hadoop. So something like this. Amazon company is going to be having a BI as well as Hadoop. Even Facebook is having BI and Hadoop. Some data they are putting into BI and some data they'll be putting into Hadoop. Even my students are working for Amazon in Hyderabad, right? So they're working for MSBI. So, and some of our, my colleagues are working for Amazon.com in Hyderabad campus. They're into Hadoop. So it doesn't mean that bigger companies will use Hadoop, smaller companies are going to be using BA. That is completely wrong way of understanding the concept. Clear? Not like that.
But
Now,
in this
what is
case,
the
oh,
tell me?
sorry.
Yeah. So let us understand what is the incremental loading. Since I need to discuss about data warehouse and OLAP, I had spoken about many things. It might be useful to you. Okay, now I have some data coming from source system, from OLTP system, and this data I wanted to dump into the data warehousing. So what normally we do, we create a SSIS package. Now we take all the data and we may transform, or if this is a cleaned data. So always I simply do the full loading. I get all the data to the destination data warehousing. Clear? Now tomorrow what happens in the fresh data? You get new more data. One more employee joins. His name is called Peter. Right? Now Peter's salary is something like this. Now HR enters the new employee data. HR database is always connected to the OLTP system. Right? So anything, if you're inserting, updating, deleting, means you are connected to OLTP database only. All of us are using OLTP databases only. You go to the bank, indirectly you're using Android mobile phone or anything, directly or indirectly when using something, we are all connected to OLTP applications. We never see OLAP applications. Now, you got some data. After 1 month, I would like to execute this. When I'm trying to execute the package, SSIS does not know that this is the new record. It is going to be taking all the data and trying to put it here. So when you put like this, what happens? You will have a lot of duplicated data. People will not be happy about duplicates. So what normally we do? So we don't dump the data like this. Before putting the data, what we're going to do? We're going to be deleting the data like this, and we're going to be dumping the data. So that is how we're going to be having it. So tomorrow, one more record comes. So let us say Bhaskar is joined in this with some salary. Now again, I would like to perform SSIS. So if I perform SSIS package ETL operations, SSIS does not know what is a new record. It's trying to take all the data and try to put like this. You will get a lot of duplicates. But if there is a primary key here, you will get errors. If there is a primary key, one cannot go again. So it is going to be getting failed. Clear? So what normally we're going to be doing, we always delete the data from the destination table, and we always take this data. That is how we're going to be doing it. That's what we have done initially also. Now, deleting the data, loading the data is perfectly fine. But now you assume a situation, you had 10 billion data here already, 10 billion rows are available. Now, one new row comes like this. For example, let us see, I have 10 billion data. 10 million data, 10 million data. This is the new row coming. So to add this guy, what are you doing? You are deleting 10 billion rows. You are loading the same 10 billion rows plus one row extra. When you do like this, do you think that you're doing a smart work? You wanted to have one more extra row to be copied from source to the destination. But to do that, what are you doing? You're deleting 10 billion data, 10 million data from here, and adding again same 10 million data as it is plus one row extra. Do you think that you're working on very smart this one? This is not at all a good way of loading the data, because SSIS does not know which row is the new row. SSIS does not know. SSIS always goes here, takes all the data. But if you give some kind of an intelligence to SSIS, hey SSIS, you take only this row and dump it here. Or tomorrow you may be having an insert. So this row got inserted, you take this row and insert. Or you may be update one row in the source. Now his salary is not 1200, it has become this much salary. So whatever be the data got updated, only you take this row and you take update. Or you may delete the data here. For example, Raj is resigned from this company. So if somebody deletes, and whenever you run SSIS package, you delete this. Clear? So this is what you should be able to do automatically with the help of SSIS. That means what? Incremental loading means whatever be the data got inserted, whenever you execute the package, only this row should be getting inserted, and this is got modified. Means this row should get updated, and if somebody is resigned from the company, only that row should be deleted. Clear? But not always deleting the complete data and loading the complete data is not the right solution. Am I clear? So as of now, SSIS is being implemented with the full loading. You take all the data from the source and dump into the destination. If you're getting a duplicated data in the destination, what are we doing? Truncate the destination table or delete all the data from the destination table, and we are loading, deleting all the data, and we're able to load all this data. So that is what we are doing, but this is not the proper thing. Clear, guys? Now how SSIS knows that this data is inserted and this data is updated, this data is deleted? How SSIS knows about it? So whenever you perform an incremental loading means it is not full loading. First time you load, for example, first time I had only 2 records. First time you load complete data, this is what is called full loading. So later, whatever be the data got inserted, for example, 3, let us say Lakshmi, okay, she got one row got inserted here. This is what is called incremental row, or this is what is called delta row, or this is what is called partial row. So this row is called incremental row. Okay, so this is what is called delta data. Let me take only delta data and try to implement it. So people will say, you take only delta. Delta means extra rows. Only that you need to insert here. Okay. So if you update somebody, if somebody updates this, only you need to update. This is what is called a delta now. If somebody updates, it is not 1800, it is 1900, got updated. So that needs to be, only delta has to go to the destination table. So how can we identify incrementals? How can we identify delta data or data which has got inserted, modified, or deleted? Clear? So this is what we need to implement with the help of these things. So types of data loading, full data loading, that's what we're doing, or incremental loading, delta loading, partial loading. How we can implement incremental loading means we can use these concepts. Use lookup, use std, slowly changing dimension, use merge statement in SQL Server to perform the incremental loading, use customized SQL code or SSIS code, or you may write a stored procedures as well. Use set operators, except, intersect, union, all of them you can use to perform the incremental loadings. Am I clear? So to perform the incremental loading, you can give many ways are available. So you can use lookup transformation to perform the incremental loading. So I'm telling how SSIS knows that. How SSIS knows that this is a delta row, right? So how can we implement? The solution is we can use lookup transformation to perform the incremental loading. Let me use now lookup transformation and perform the incremental loading. Okay, let me go. So let me delete everything. So this is a situation for you. Okay, you have created a source table. Now you have a destination table, and day one you don't have any data, and you create a primary key and everything. Remember, to create to work with incremental loading, this is very important question. Okay, if you wanted to implement incremental loading with the lookup, std, whatever you wanted to use, you can use, there is no issue. But what is the prerequisite? Prerequisite is your source table should have a primary key or a business key, some key you need to have in this. Clear? If the source is not having a primary key, if you don't have a primary key, you may have duplicated data as well, like this, right? So if you have a duplicated data in the source, can we perform incremental loading? Answer is no. Including Bill Gates or Satya Nadella, nobody can do incremental loading in this world. Nobody can do. If you wanted to perform incremental loading, what is the prerequisite? Source table, not the destination. I'm not talking about the source. Destination you may give, you may not give, doesn't matter. But in this, you may need to have a primary key or a business key. Business key means it is not having any duplicate data. Primary key means it is not having duplicate data. So it is a key. You have to have one column as a key column. Remember this point. If you don't have a key column in the source means you cannot perform any incremental loading. Remember this point forever. People would ask you, what is the prerequisite to perform incremental loading? You must say source system should have a primary key in the data. If you don't have a primary key, then we cannot talk about this at all. Incremental loading, delta loading, partial loading cannot be implemented for any guy in this world. Even you ask Aristotle or Plato, whoever it is, who or any guy, even Einstein also cannot implement this. Clear? Remember this point forever. Source system should have a primary key. Now, how SSIS knows that if I insert a new row, how SSIS knows that this is the new row I have to insert here? Let us do this activity. Now, what we do? To read the data, what normally we're going to be doing? We're going to be doing OLEDB source. Okay. So data may be coming from OLEDB, may be coming from the flat files or Excel sheets, doesn't matter. You take this completed data and we have to load it here. We create this table as a blank and this is having data. Clear? Now, after that, what I do, I create a lookup transformation. Lookup already you know, right? Lookup transformation I will perform. So this is what I'm going to be doing now. Incremental loading with the lookup transformation. So when I create a lookup will have a reference table. So I am going to be taking this as a reference table. This is my destination table and I'm going to be using this as my reference table. Now, when you give a reference table, you need to map some columns, right? So I'm going to be using source employee ID is equals to destination employee ID. So this and this, I am mapping this employee ID, this employee ID, I'm mapping. So this one, and I'm going to be mapping with this data. Clear? But one is going to be mapping with one. You don't have any matching data. So one doesn't have any matching. It will become unmatched data, or you can say no match data. Clear? So no match data, and this side I'm going to be getting matched data. There are two types of data you will be able to get. One is called matched, the other one is called unmatched. Okay, let me take. So this is matched data. This is unmatched data. One and one is not matching. If it is not matching, what should I do? So one, I don't have any matching records. So this record is going to be coming here as an unmatched data. And two, I don't have any matching. So two, this record is going to be coming as unmatched data to this. Now from here, what I do, I take one OLEDB destination. I link this to here. Okay, so all the data is going to go to here. OLEDB destination is again this table, right? So this table is connected to two places. One is called lookup is opening this as a reference table, and OLEDB destination is using as a destination table. All the data will come. So these rows it is going to be inserting into here. Clear? So that is what you need to understand. All unmatched data is going to come from here. This data will come and it's going to be inserted. That it will get deleted because after that nothing will be there. So these two rows are went here. Now let me go insert this. Let me remove matching as of now. Okay. Let me have next one is called Lakshmi. Let us say 2400. Let us start this. All the data is going to be read one by one, one by one. One and one is matching. I'm not, capturing this as of now. So one and one is matching. Forget about it. Two and two is matching. Forget about it. Three doesn't have any matching. This record is going to come here. This record is going to come here. Now this record will go, and from this one, it is going to go there. And so, okay. Whenever you insert one more row, always it will get no match data. No match data will go to OLEDB destination. It's going to go there. Okay. Now what about the matched data? For the matched data, we're going to be updating it. So when you have a matched data, I'm going to be using OLEDB command to update. Remember this, okay? So here we are going to be using insert. Unmatched data will get inserted, here. So whatever be the matched data, 1 and 1 is matching. This record, for example, this got modified to 2400, or it is modified to 1900. Something like this, it got modified. Now, when I say 1 and 1 is matching, this record is going to come here. This record is going to come because matching. 2 and 2 is matching. So this record is also going to come this side. Okay. And 3 and 3 is matching. This record is going to come this side. Okay. But if you have any other row, that will come because I don't have any extra data here. I did not come. But if you have extra data here for, let us say Peter, and let us say 3000, this row is going to go this side because this is one unmatched data. Clear? So no matched data will come this side. I have a Peter, it is come this side. So matched data comes this side. So this data is going to go here. Using this, it is going to getting inserted here. Okay. So that is what will happen. Then the matched data, what I'm trying to do, I am trying to, here I'm going to be inserting into the table. Here I'm going to be using update statement. Clear? So I update this guy. So how do I update? I'll say I have to write like this. So I'll say update. What table I have to update? This table. So dim employee and set. What all I need to update? I need to update because we should not update this column because this column will not get updated anytime. Primary key columns will not get updated, right? So 1 cannot become 11. So nobody should update the data like this. If they update the primary key, then you're gone. So nobody is going to be, changing the primary keys every time. So primary keys, once it is given, this is read-only data forever. So these remaining columns will get updated. Your name may change, your salary may change. Even name cannot change forever, but salary will change always, right? So you say update what? This table. What all I need to update? Name and salary. I'll say set name name, and I put question mark, comma, salary, I put question mark, and where employee ID is equivalent to question mark. So this is what I have to give it here. So what is the meaning of this? I wanted to update name. I wanted to update salary where employee ID equals to 1. So we know OLEDB command is going to be working row by row. That's what I told you. If you wanted to update in SSIS package, we're going to be using OLEDB command. So OLEDB command always gets one row at a time. So this row is going to come down now. Okay, this row is going to come down to OLTP. Now what is the command I have written? I have written update. So this is the command I have written, dim employee. I set equals to name. What name? This name. This name is equivalent to, I put a question mark. Okay, comma, salary is equivalent to question mark, and I said where employee ID equals to question mark. That's what I told. I have given. So one row it will come here. So this is the command I have written. Now I have to map what is this question mark. What is the meaning of this? What is the meaning of this question mark? What is the meaning of this question mark? That means the data going to come dynamically. That is the meaning of this. Question mark means I don't know what is the data, but it is going to be supplied dynamically. So I have to map. This first question mark is called as a 0th question mark. There is a numbering. The first question mark is called as a 0. This question mark is called as a 1. In SSIS, always it's start with 0, and this question mark is called as a second question mark. We have a indexing number. Your first guy, second guy, third guy. When I'm saying first guy, that is Kabir. When I'm saying second guy, that is Gaurav. When I'm saying third guy, that is say Ravina. So I'm giving a number, or I can say Ravina or Gaurav or Kabir. I can give the name, salary, employee ID, or I can say first guy, second guy, third guy. I can say zero guy, one guy, second guy. So zero guy means I'm mapping. What is zero? Zero means name. So here I'll say this is zero. I have to map. So salary is what? Salary is one. So this map to be with one, and employee ID is 2. This is mapped to 2. Clear? So this question mark need to be mapped like this. 0 means what? Name. So where is the name? Name, it is here. So this is the name. You map to 0. So what is salary? Salary is 1. So 1 means where is salary? Salary is this, it is 1. So then what is employee ID? Employee ID is 2. So this is employee ID. So this you need to map. Clear? So if you use the updates also will happen. So this row will update. So for one, this will get updated. So this 1900 will get updated here, and even this John also will get updated here. Now, once it is updated, the next row comes in. Control C, the next row comes in here. Next row, 2000 will get updated here. Raj will get updated here. Then it is also done. Now the next record is going to be this record. It's going to become here. 2400 will get updated. Lakshmi will get updated. But unfortunately, these two records will not get updated in the source. But now what I'm doing, I am updating all matched data. Okay, I'm updating all matched data, but unnecessarily I'm updating. But we cannot do anything as of now. So this is how we need to implement OLEDB command. Clear? So we're updating all matched data, blindly update. Whether it is updated or not, forget about it. Simply get all matched data. You update it. Whatever be the extra row, that we're going to be putting it here. Clear? So in the data warehousing, nobody is going to be deleting the data. Remember this. Data warehouse, even though everybody resigned from the company, these people have resigned, deleted the data. But even though you delete the data from the source system, your data warehousing concept should not delete the data. Remember? So you never implement a delete operation in the incremental loading. Clear? But if they wanted to implement, we can implement. It is not that technical, it is not possible. Technical possible. But data warehouse, remember, data warehouse will not accept any deletions, only insert and update. Clear? Even though you delete complete data from here, this data should be stored in your data warehousing. Am I clear? So data warehousing system will have only inserts and updates. Incremental insert, incremental update will be there. So delete is not implemented in any real-time data warehousing. Clear? Remember, if you wanted to implement it, definitely we have different techniques to implement it, but we are not going to be implementing deletions. So always we try to perform lookup transformation. I try to use no match data will go as an insert, matched data will go as an update. Now we're going to be using OLEDB command transformation here, and it is going to be getting row by row, row by row. With the help of this command, we're going to be updating the data here. Tomorrow, I'm going to be showcasing this demo. Okay, so we'll have a lookup, and after the demo, then we'll see some more things, because unnecessarily, whether it is a matched or unmatched, I'm updating. I wanted to identify only completely unmatched data, because this may be 1900, it is there. So tomorrow, this salary is getting to 400. So all matched data is going to come when you're implementing this logic. Okay, you update all the data once again. So that is not. Out of this, which row got updated? Only this row. So only I need to take this row and send it here, and I need to update only that row. But as of now, I'm updating all the rows with this command. Okay, tomorrow we'll change this logic as well, and we'll try to do incremental loading with the lookup transformation. Am I clear? So this is what is called lookup. Many companies are going to be implementing lookup transformation to perform the incremental loading. Clear? So we have lookup transformation can be used to perform the incremental loading. So that we do the demo tomorrow. Thank you guys. Any questions?